It is 7 o'clock in the morning on a steep, windswept slope above the Cheyenne River drainage just outside Valley City, North Dakota. Dr. Donald R. Kirby stands knee-deep in a dense sea of green, looking out across the rugged drops of the valley. The air is cool, carrying the scent of damp earth and the faint, bitter smell of broken plant stems. Beneath his boots, the ground is choked by an aggressive, yellow-green plant that seems to swallow every square inch of the native prairie. Beside him, Robert B. Carlson, an entomology professor from North Dakota State University, kneels to examine the base of a thick, woody stem. To any rancher standing on this ridge in the late 20th century, the hillside looks like a battle already lost. The plant is leafy spurge, an invasive weed that has marched across millions of acres of American rangeland, rendering vast pastures useless for grazing. Nearly 200 stems crowd every square yard of soil, suffocating the grasses that local cattle depend on. And yet, these two men have not come to spray a single gallon of herbicide or set a single match to the prairie. They have come to watch the weed lose. Because in a region where millions of dollars and decades of labor failed to stop this invasion, the rescue of the northern Great Plains would not arrive from machinery, chemical laboratories, or government mandate. It would arrive from a creature so small it could sit on the head of a match, and it would do the job for free. To understand how a single plant brought an entire agricultural region to its knees, you have to go back to 1827. In the coastal town of Newbury, Massachusetts, a merchant ship arriving from the far side of Eurasia dumped its heavy ballast soil onto a local shipping dump. Mixed in that discarded earth were the tiny, resilient seeds of Euphorbia esula. Leafy spurge. No one paid the newcomer any attention. It was a quiet hitchhiker, a botanical opportunist waiting for the right conditions to explode across a continent, and human progress soon handed it every vector it needed. As settlers pushed westward, breaking the native sod of the American interior, they carried contaminated seed stalks of smooth brome and cereal grains. Every wagon train, every newly laid railroad, every bag of imported seed became an unintended distribution network. The spread accelerated in the late 19th century, and by 1899, the first official Canadian record appeared in Ontario, confirming that the invasion had crossed an international border on a wide and moving front. By the early 20th century, the plant was no longer a scattering of curiosities. It had taken a permanent, aggressive foothold across the northern United States and southern Canada, converting diverse prairie into monocultural barrens. The damage left in its wake was catastrophic for the people trying to survive on that land, because leafy spurge is not a weed that merely takes up space. It is a toxic usurper. The plant bleeds a thick, milky white latex that irritates the digestive tract of cattle, causing blistering and illness if eaten. So cattle refuse it. They will not graze anywhere near it, even when healthy forage grows directly beneath the yellow-green canopy. As the weed multiplied, the grazing capacity of the rangeland collapsed. In North Dakota alone, it eventually occupied roughly 850,000 acres, nearly 9% of the state's untilled land. A North Dakota State University economic study put hard numbers to the ruin: an annual loss of about 580,000 animal unit months, enough forage to feed 77,000 cows for a month, gone. For ranchers, that meant millions in lost net income every year. The ripples spread far beyond the fence lines, draining tens of millions of dollars from regional business activity. Across the four-state region of Montana, North Dakota, South Dakota, and Wyoming, the estimated annual impact climbed to roughly $130 million, and the ecological cost was just as steep. The weed displaced native grasses and wildflowers, erased the species diversity that local wildlife depended on, and crowded even rare plants like the western prairie fringed orchid toward the edge of survival. Faced with a catastrophe of that scale, ranchers and land managers launched an all-out war. They deployed every weapon in the modern agricultural arsenal. They poured money into chemical herbicides, spraying from the backs of trucks, from tractors, from airplanes. They mowed the stalks before the seeds could drop. They turned the soil over and over with intensive cultivation. They set the prairie ablaze in controlled burns. They sent crews into the dirt for backbreaking hours of hand-pulling and grubbing. They even brought in herds of sheep and goats, animals that tolerate the toxic latex better than cattle, to graze the weed down to the nub. No poison explained it, no fire contained it. No amount of human sweat could hold the line. The flaw in this war was a deep misunderstanding of the enemy. While the ranchers fought the green stalks above the surface, the real power of Leafy's spurge sat untouched below it. The spraying programs were not just temporary, they were financially ruinous. In many places, the cost of the repeated herbicide applications needed to suppress the weed exceeded the market value of the land itself. And the geography of the northern plains made wide chemical attack physically impossible. The worst infestations clung to steep river slopes, dense woodlands, fragile wetlands, and riparian zones along the water, exactly the places where spraying poison would do unacceptable collateral damage. The brute force approach stalled completely, leaving behind scarred ground, emptied bank accounts, and a weed that seemed to thicken with every passing season. During the worst of it, a story of despair took hold. A claim circulated through media reports that leafy spurge was an almost supernatural emergency, a botanical monster doubling its territory every 5 years in defiance of ecology itself. But when researchers went to the long-term records, a more accurate picture emerged. The United States Forest Service reviewed the historical data and dismantled the 5-year doubling myth. The real annual spread rate in North Dakota, measured from 1909 to 2002, hovered around 16%, with the broader national rate later cited between 12 and 16%. The plant was aggressive, but it was not an alien thing operating outside the laws of nature, and that reframed the entire problem. The weed was not spreading too fast to catch. The weed was, in fact, completely vulnerable to long-term biological pressure, provided that pressure was applied in exactly the right place. Humans were not losing because the invasion was unbeatable. They were losing because they were fighting the wrong part of the plant. To see why, you have to look underground, into the machinery of its biology. Euphorbia essula is a deep-rooted perennial that grows between 8 and 35 inches tall, flowers early to beat the native vegetation, and reproduces 2 ways at once. Above ground, its seeds ride in specialized 3-celled capsules that behave like miniature artillery. When they dry, they explode, flinging seeds up to 15 feet from the parent plant, and those seeds can wait in the soil for up to 8 years before they germinate. But the seeds are only the scouting parties. The true engine of its persistence is below. The root system of a single plant is a massive, woody labyrinth that can drive nearly 15 feet down into the subsoil, a colossal storage battery packed with starches that let the plant shrug off drought, fire, and repeated mowing. Worse, those roots carry hundreds of latent buds. Cut the stem or burn the foliage to ash, and the underground buds wake instantly, drawing on that deep reserve to send up dozens of new shoots in place of the one that was lost. For every inch of plant visible above the soil, yards of nutrient-rich biomass hide safely beneath it. When a herbicide kills the top growth, it barely scratches the reservoir below. If the hidden engineering behind problems like this is the kind of story you come here for, consider subscribing. These buried systems are exactly what this channel exists to take apart. Defeating that root system required an equally specialized piece of biological machinery, and it arrived in the form of the Aphthona flea beetle. 3 species in particular, Aphthona lacritosa, Aphthona tsawalinae, and Aphthona nigroscutis, carry a life cycle tuned to the weed's exact weakness. The adult beetles spend their brief summers above ground, nibbling the leaves and bracts, but that feeding barely matters. The real destruction is the work of the larvae. After hatching from eggs laid at the base of the stem, the microscopic larvae burrow straight into the soil, fasten onto the spurge roots, and begin to feed. They do not nibble the edges. They devour the fine root hairs and tunnel into the main root structures, doing two things at once: draining the plant's stored energy and destroying the very buds responsible for regrowth. The results of that underground assault were nothing short of revolutionary. Beginning with controlled releases in 1988 and 1989 at sites near Valley City, North Dakota, the beetles established their populations and then did something no spray crew ever could. They did not ask permission. They required no fuel, no labor, and no second application. They simply spread across the landscape on their own. At the monitored release sites, the numbers astonished longtime land managers. Before the beetles, leafy spurge cover at the study sites stood at a suffocating 44%. After several years of continuous larval feeding, it fell to 7. The stem density, once a dense thicket of roughly 180 stems per square yard, collapsed to about 5. The wall is gone. The root data confirmed the kill. The dry weight of spurge roots in a given volume of soil dropped from around 5 ounces to 1. The number of living root buds in that same soil fell from more than 80 to fewer than 20. The underground battery of the invasion had been drained of its charge. And here is the counterintuitive heart of the whole victory. The beetles never had to kill every plant. Total eradication was a human fantasy, born of brute force thinking. The beetles only had to hold the root system down long enough for the native prairie to recover its footing. Once the spurge lost its underground energy advantage, the native grasses rose, yields climbing by roughly 50% over the study period, and simply reclaimed the open ground, outcompeting the weakened weed for light. It was a pincer movement. The beetle starved the roots from below while the returning grass stole the sunlight from above, and between them they built a stable, self-sustaining loop. Layer in careful management on top, competitive grass plantings, the occasional targeted herbicide spot treatment on the stubborn patches, and the control became permanent rather than seasonal. That shift from chemical warfare to biology rewrote the economics of the entire region. For decades, leafy spurge had quietly sustained a market. Herbicide manufacturers, spraying contractors, heavy equipment operators, all funded by the desperation of ranchers trying to protect their land. It was a loss-driven economy, an endless bill with no final payment. The four-state impact had run to roughly $130 million a year. When the Aphthona beetles arrived, they broke the cycle, because a beetle that reproduces and spreads on its own costs almost nothing after the first collection and release, and the projected payoff is enormous. One long-term analysis estimated that if flea beetle control reached 65% of the remaining infestations across the 4 states, it would cut the weed's annual economic impact by $58.4 million. An endless string of expensive temporary sprayings replaced by a self-replicating insect that works for free. The equation flipped from a permanent loss into a permanent saving. And this is not an isolated story. The same pattern keeps surfacing across the country wherever human force has tried and failed to engineer its way out of an ecological imbalance. Consider the zebra mussel in the Great Lakes, which drove water managers to abandon reactive cleanup for ecosystem-scale prevention. Look at kudzu in the American South, the textbook invader that outran every mower and every sprayer, swallowing landscapes faster than crews could cut. Watch salt cedar choke the riverways of the West until managers traded their bulldozers for biological control beetles. Consider purple leucostrife in the eastern wetlands, an ornamental import whose containment finally turned on the release of leaf-feeding beetles. Or cheatgrass across the Great Basin, where wildfire feedback loops matter far more than any single removal. Each case teaches the same lesson. An ecosystem is a vast, interconnected web of living relationships, not a machine to be fixed with a bigger hammer. When we break these systems, force tends to deepen the damage, while the real repairs almost always come from working with the patient logic of biology rather than against it. Back on the steep slopes above the Cheyenne River, the afternoon sun is dropping toward the horizon, throwing long shadows across the drainage. Dr. Kirby and Professor Carlson climb the ridge toward their vehicle, their boots brushing through a thick stand of native prairie grass that has not stood on this hillside in decades. Near the top, Kirby stops and looks back over the green. The yellow-green blanket that once threatened to bankrupt the region has pulled back into a few scattered, manageable patches, held in permanent check by millions of microscopic larvae working quietly beneath the sod. The rescue of the American rangeland required no technological miracle and no endless chemical war. It required only the humility to step back and let a beetle the size of a match head do the work. So when we introduce one organism to undo the damage of another, are we truly restoring the balance of nature? Or are we simply setting the stage for the next chain reaction we cannot yet see?